In October 2022, during the Orionid's meteor shower, a fireball was captured on camera in North America. Other meteors left long streaks of glowing debris in the sky. A little earlier, in March 2022, an asteroid crashed into Earth's atmosphere and was captured by one of the meteorological satellites. Fortunately, the asteroid, named 2022 EB5, was only 2 meters (6.5 feet) wide, so it didn't result in a catastrophe. But not all cosmic collisions are so safe. Some of them are powerful enough to damage planets or even lead to their destruction. What explosion captured on camera is hundreds of times the power of our entire nuclear arsenal. Which cosmic explosion left a void the size of many galaxies around it? And what single meteorite triggered the creation of an Earth defense program? LOGO. Scientists often observe cosmic calamities, and in 1993, they were preparing to watch the comet Shoemaker-Levy 9, SL9, crash into Jupiter by 1994. But at the very last moment, it turned out that the collision would occur on the night side of Jupiter, and the initial impact wouldn't be visible from Earth. Only NASA's Galileo spacecraft, which was on its way to the gas planet, had a front row seat for the spectacle. The space probe captured the comet entering Jupiter's atmosphere at about 60 kilometers per second, 37 miles per second. With 1-second intervals, Galileo took a series of images showing the appearance of a fireball and recorded its peak temperature of 23,700 degrees Celsius, 42,700 degrees Fahrenheit. Soon Jupiter, which makes a complete rotation on its axis in just 10 hours, allowed this fireball to be seen from Earth. Then NASA's infrared telescope captured a fragment of SL9 that was still rising above the edge of the planet after the initial impact on the night side of Jupiter. But the best images were made by the Hubble telescope using a high-resolution camera. The telescope was broadcasting at least once a day for a week. Slowly, as the planet rotated, it showed dark spots on Jupiter left from the impact of the comet fragments. The Hubble Space Telescope has recorded the collision of 21 SL9 fragments with the gas giant. The image showed fragments of the comet stretching nearly 1,140 kilometers, 710,000 miles, which is about 3 times the distance from Earth to the Moon. Other observatories and telescopes also kept a constant watch. The largest impact was caused by a huge fragment of a comet named Fragment G. The result was a giant dark spot on the surface of the planet, more than 12,000 kilometers, 7,500 miles across. This is almost the diameter of the entire Earth. According to some estimates, the explosion released energy equivalent to 6 million megatons of TNT. At the time, this was 600 times the explosive power of the entire nuclear arsenal of the world. Meanwhile, the impacts continued. At an interval of 12 hours, 2 more explosions followed, leaving trails almost as large as the G fragment left. The collision sent gigantic plumes of debris flying into space, rising 3,000 kilometers, 1,900 miles above the cloud tops. A few minutes later, they plummeted back to the planet's surface, turning it again into a blazing furnace of flames. In addition, the collisions generated huge waves of energy that swept across Jupiter at 450 meters per second, 1,476 feet per second. The spots from this impact were visible on the surface of the gas giant for many months, and some were even more noticeable than the famous Great Red Spot. But regardless of how big the catastrophe was, it provided astronomers with many valuable insights. When debris from the comet crashed into Jupiter, scientists had a momentary window to look into the gas giant's atmosphere. Material from the lower layers was ejected into the dense upper clouds, and astronomers learned more about the planet's chemical composition. Researchers found 2-atom sulfur and sulfur carbon, as well as the emission of heavy atoms of iron, magnesium, and silicon. Instruments have also detected a layer of water in the atmosphere, though less significant than expected. Researchers believe that a more water-bearing layer may be hiding deeper in the atmosphere, where the SL9 fragments didn't penetrate. The impact event not only helped scientists track wind movements, but also revealed the effects of comet and asteroid particles on the magnetosphere through changes in the polar lights of the gas giant. While Jupiter's gravity captures most celestial bodies, the frequency of comets and asteroids colliding with Jupiter is believed to be 2,000 to 8,000 times higher than on Earth. Although Jupiter acts as a cosmic vacuum cleaner, it cannot guarantee our safety all the time, as evidenced by impact craters on the Moon, Mars, Venus, and Earth. The extinction of dinosaurs resulted from a massive asteroid impact, emphasizing the need for Earth's protection from such celestial visitors. In Halloween 2022, a huge asteroid named 2022 RM4 passed close to Earth, reaching a diameter nearly equal to the height of the Burj Khalifa in Dubai. This fast-moving celestial object was captured by the Virtual Telescope project in Italy, flying by at a speed about 68 times the speed of sound and a distance of 2.3 million kilometers from Earth the next day. That is about 6 times farther than the average distance from Earth to the Moon, but still very close by cosmic standards. So our solar system is a much more peaceful place than it was 4.5 million years ago. There's still a lot happening here. Some random celestial rock can one day easily damage Earth. Just SL9 damaged Jupiter. To prevent this possible catastrophe, it was decided to build a reliable line of defense against comets and asteroids. And the first step was the identification of potentially hazardous objects in space. Until the mid-1990s, only a few teams of astronomers were searching for asteroids in the inner solar system. But after the Shoemaker-Levy comet hit Jupiter, we came up with the term planetary defense, and new teams joined the research. Scientists now work together to track near-Earth objects, especially asteroids that come within 48 million kilometers, 30 million miles of Earth's orbit. NASA has already detected 90% of potentially dangerous asteroids that are 1 kilometer or larger. The agency is now working to identify at least 90% of asteroids between 140 to 1,000 meters, 450 to 3,300 feet wide. At the same time, space organizations around the world are looking for ways to deflect orbits of celestial bodies that threaten our planet. In September 2022, the Darity spacecraft diverted the asteroid Dimorphos by changing its orbit in the very first test of Earth's defense system. China has also planned a mission to alter the flight of the asteroid 2020 PN1 in 2026. Scientists have often observed powerful explosions in distant star systems and galaxies. One such event occurred in the Ophiuchus galaxy cluster, resulting in a massive flash that created a cavity equivalent to 15 Milky Way galaxies. This extraordinary event, captured by multiple telescopes, took place approximately 390 million light-years from Earth. The data collected from NASA's Chandra X-ray Observatory, ESA's XMN Newton, the Murchison Wide Field Array, and the Giant Metrowave Radio Telescope allowed for an in-depth study of this event. In October 2022, NASA detected an explosion caused by a black hole's birth 1.9 billion years ago in the Sagitta constellation. This explosion, known as GRB 221009A, released a wave of X-rays and gamma rays that reached our solar system. The Fermi and time due to its distance and minimal radiation reaching us. However, had it been closer, the destructive power of a gamma-ray flood could have vaporized the atmosphere and annihilated life. Evidence suggests that Earth experienced a similar event 445 million years ago, causing a massive extinction. The culprit may have been a supernova explosion near the Milky